welcome all of you, right?
Absolutely.
Yeah. Yes. Good afternoon, and thank you so much for joining. A warm welcome to all the participants over here. Myself, Gautami, and we are hosting this webinar, Intelligent Test for Semiconductor and Electronic Devices and a Startup Mitra program, from IESA, right? And today, to talk about or to speak about this topic, we have our distinguished speaker, called Marvin Landrell. Thank you so much for joining. I know it's too bit early, but then, we appreciate your time. So he's a director software strategy for semiconductor electronics. Now it's Emerson Test and Measurement. Formerly it was NI. Um, he has spent more than 20 years in the semiconductor and electronics industry.
Effort. Yeah.
Request everyone to mute yourself.
With time, technology will evolve और चीजें होती रहेंगी. That is going to happen. But हाँ, HFT में थोड़ा धीरे-धीरे हुआ है.
नहीं agree.
Yeah. So he has spent more than 20 years in the semiconductor and electronics industry, where he was responsible for several highly successful worldwide standardization efforts in the automated bench validation space. As a head of software strategy, Marvin uses his industry expertise to direct the Emerson test and measurement roadmap in a way that brings technical and business value to the entire semiconductor and electronics market. So I think today it is going to be a very insightful and interesting topic for all of our, the attendees. So over to you, Marvin. And I request everyone to mute yourself, and then probably if you have any questions to take it up in the last Q&A section, you can also post your questions in the chat box where Marvin will handle it in the last 15 minutes. Thank you so much. Over to you, Marvin.
Excellent. Thank you very much for the kind introduction, and thanks everyone for attendance. Quite a good sized audience, which I really appreciate. Yeah, I'm always glad to be up early. I have worked with my counterparts in India for 25 years, and this is a dance that I'm quite familiar with, and always glad to do it. As the introduction mentioned, I have spent about 25 years in semiconductor and electronics. The first 20 was embedded in a very large semiconductor company that is out of Dallas, Texas. So I'm sure you can guess which one that is. And I spent that entire time building, deploying, supporting enterprise level infrastructure for validation and test. And then spent the last 5 years, in industry. NI was always one of my primary partners and vendors, and then I jumped over to join NI about 5 or 6 years ago. I won't bore you with the details of that journey, but I've been in the semiconductor and electronics business unit, which is a vertical inside of NI, which is now part of Emerson, which is what I'll talk about. So I have been on both sides of the coin, and I have became very familiar with the strengths and weaknesses of the various test and measurement vendors and partners and their tools, and how easy or difficult it is to integrate everything together and get my job done. So I've spent my 5 years on the other side helping NI understand that perspective, and we've made a lot of very exciting changes, and there's more to come. So I'll leave that at that. So, AI is going to be obviously one of the biggest disruptors, the biggest technology infections that we've seen in many industries. And I'm here to help you understand how it could also it will be an important disruptor inside of what we call the test and measurement industry as well. The first tool that humans have invented that helps you get better use out of other tools. There's a lot of ways to think about AI and the value that it can bring into test and measurement. And I'm excited to start unveiling some of that here. From a little history perspective, if you know NI, or what used to be called National Instruments, we've spent decades innovating in test and measurement, and not just around instrumentation, right? Around disruptive software. and technologies, and then in most recent years, enterprise data infrastructure as well. And then again, in addition to the hardware. So we play in the full space. I'm excited to be one of my first presentations uh, under the Emerson umbrella. And was acquired going on 2 years ago now. If you have not looked at Emerson Electric lately, I encourage you to do so, depending on your age and what you remember. Emerson, has been around for a long time, but it is a very innovative company now that has chartered a path towards what they call pure play automation, and they acquired NI as their flagship business inside of test and measurement, and that is been a huge win-win, not just for Emerson and the acquisition, but for NI having the power of Emerson to tap into, and I'll talk a little bit about that as well. Um, so, actually, if you Google Emerson, Google Emerson and boundless automation. So I'm not in any way in position to talk about Emerson's platform, but I know enough of it to to help understand how the investment that Emerson has been making for a long time now on things that they call a unifying software fabric, the ability to democratize your data across your silos and your verticals and your horizontals. Um, addressing how you turn your data lake into something that can really extract value. Emerson's been in this space for a while. They're focused on industrial automation more than test and measurement, but it's a very big complement. So NI's roadmap has been greatly accelerated through this acquisition. So what you see here on this slide, the areas, think of the test and measurement vendors out there, and then and think of where they play or where their strengths are. As I mentioned, NI from the very beginning wasn't just building hardware, starting with PC-based data acquisition. They were always investing in software, starting with Visa, GPIB, then disruptive software like LabVIEW and Testan, now enterprise data solutions. So very much a strong hardware platform that is positioned to take advantage of AI. Obviously, the highly scalable and connected software, and now moving into digital transformation that will be highly accelerated and enabled by the innovations in AI worldwide. So, kind of pause. This is a thinking slide for everyone, meaning that okay, we know AI is evolving very rapidly, and you hear all the kinds of stories about what's possible through AI. And then you meet different types of people. You meet the dreamers and the doomers, as the slide calls out in here. You meet people who believe that it's just a buzzword. I think those people are a lot quieter these days in recent innovations. But you also have your doomers. Where are you and where is your organization? What is your mindset on what actual value are you hoping to extract from AI in your semiconductor and electronic space, whether it be the lab or in production? What are we, what value are you trying to get? Well, that's what NI has been working on for several years now, which is how are we actually going to apply this technology in the test and measurement, characterization, validation, and production space centered around an electronics and semiconductor world. And I'm going to give a glimpse of that today, but also there's a lot more to come. But I think that's the main thing is get yourself grounded in what value are you trying to extract in your workflows, and what steps do you need to do as a company, as an organization, or even as an individual to actually make sure that your ecosystem or your world is prepared to take advantage of that? Because it is very possible, and I've already seen it, that organizations are driving for innovation in this space, but they aren't ready. Things in their world are not ready to be interrogated by AI, if you will. And again, I'll provide some details of what I'm talking about, but that is what I'd like you to get your head around as you think through this material, or you see this material of what are we actually trying to accomplish together in this space. Okay. A very important slide here. So this is kind of leveled all the way up to think of, okay, we're we want to be the leader of AI and test and measurement. What is it important for you and industry leaders to understand? First and foremost, we absolutely embrace the idea that you are the expert, right? You always need to be in charge, and make final decisions. Everything that we do will be centered around that paradigm, if you will. So we want to empower you. So jumping over to AI enhanced, how are we trying to do that? Well, we're trying to meet you where you are. We're not trying to extract you out of your world and put you in an AI space where you need to be the guru in AI. We're trying to accelerate your existing workflows, accelerate your use of your existing tools, help you get more value out of your product and out of your data, make smarter decisions faster. That's how we're trying to do it. And, always very important to keep in mind in the center, industry ready. We understand, and when I say we, this really does start at Emerson, who um, have made quite a path down this lane already, which is your data and your IP are the lifeblood of your company, and it is critical that we help you protect it. We're committed to adopting the best practices in data security and privacy. We're partnering with key leaders like Microsoft. We are committed to be transparent in our use of AI, enabling opt-outs at all the right levels, and we will always have clear terms of data use and protection. So just wanted to get that out of the way, in terms of concerns that you and your organization may have. This will be challenging, but we are starting from the right place from the very beginning. Okay, so this is okay. If you're not familiar with NI at its core, especially the semiconductor and electronics business unit, which I represent, right? We understand the new product development flow for electronics and semiconductor. There are industry, experts or leaders like myself that have been in semiconductor and electronics for 20 plus years. The whole business unit was built along that line. Our leader, now the president of Emerson Test and Measurement, it came from semiconductor, Motorola Freescale days. So, we understand that workflow, and then we have tailored our hardware and our software to add value in that space. So we understand as the product moves from simulation and modeling into the lab for wake up and debug and validation, characterization, high volume validation, high volume manufacturing, and all about quality and reliability, regardless of your product or your application. And then you see down there again, because we believe we're the only test and measurement vendor that plays equally in hardware, software, data, right? So we're in a position to create an ecosystem that extracts value out of that entire workflow. So now let me take you to an analogy, help paint a little bit of a picture. Now, I am not an AI expert. As I mentioned, I am an industry, leader. But obviously, as a software leader for the organization, I've done my homework and I have talked to the experts, and I'm want to try to bring this in a way that people can get their heads around it. So what you see here obviously is one of the more sexy examples of where AI can be applied. I've got here art and image detection and art and image transfer. Okay, so there are engines now out there that have been tuned and trained to be able to interrogate an image, not just any image, but even artwork. So, if you feed an engine all the Van Gogh paintings in existence, and not just look for images. So we know the technology where you can find all the pictures of cats on your iPhone, but now we're looking at brushstrokes, technique, color palettes, style, whatever that means to AI, right? So the added programming or the added training where AI can extract and understand what a Van Gogh painting is, right? In AI speak. But then flip it on its head and use the other tools that know how to create images and train them to use those techniques. And in this example here, okay, take my image of a landscape and turn it into a Van Gogh like, city landscape painting. Okay, so idea of detection and transfer, right? Very sexy, very cutting edge AI capabilities. But let's look at test and measurement. Not nearly as sexy from that perspective, but it's the world that we all live in. So what is the equivalent? What is it? What does AI need to detect and what is it needing to transfer? So detection, there are different ways of bucketizing it. The way I'm bucketizing it for this presentation is you're dealing with requirements, you're dealing with test platforms or test systems, whether they be in the lab or in the production floor. You're dealing with IP, let's call it measurement IP, that produces the data that makes the measurements that you need for your workflow. And then, of course, the resulting data for that. So that's the ways. So now AI for us, if we're trying to enable AI value, we need to teach and train a model to extract, well, to break down and analyze these components in a way that is prepared then to help transfer that knowledge into AI magic for test and measurement. Okay, where are we going to apply that AI magic? We're going to apply it in a couple of areas. Excuse me. Obviously, engineering productivity. Okay, if we know enough about these components at the top, we can produce and help you do things in your workflow faster than you could do them on your own, or that you can do today, right? Data insights, again, if we know enough about your data and your requirements and your IP, we can create a AI tuned test and measurement engine that can help you get value from your data faster, right? Operations, analyzing your fleet of testers or your lab benches, understanding what instruments are attached, understanding the specs of those platforms, what they can do, and then helping you find underutilized assets or underutilized platforms, or help you optimize your overall operations in your lab. And then just actual capability, as the product you innovate products and create new specifications. Now you have to innovate your platforms to match those specifications, and what help can we help you there create the new platform capability faster and take advantage of it. So as I said, left and right, sexy, not sexy, but this is the mindset that we have to get ourselves into if we really want to say, okay, I want to apply AI in my world. And NI is committed to and is already starting down the path to creating the test and measurement trained LLMs that can do these sorts of things. And we can get more specific here. So again, back on detection. I think I've hit a lot of this stuff, but okay, the real question is, if an AI model is aimed at your IP or aimed at your data, one, can it find it? Right? Is it in a way that an AI model can locate your data? Two, is it contextually aware? Is it meta rich, right? Does it have the knowledge that needs to be extracted in order to produce value? And what I'm seeing across the industry is this is one of the biggest gaps, right? Yes, you could train an AI model to look at any data in any format. But then what you're going to do is you're going to use a lot of prompt engineering, a lot of time to teach the model about your specific data and your specific structure. You know, the team next to you has a little bit slightly different structure. So the AI will spend a lot of its time in that world versus already understanding the schema or the context of the data in a global way. And now you're using your time working with AI to extract real value. So in that, I can say the same thing about all of these blocks, right? What about your IP? Can AI find your IP? If it can find your IP, can it extract anything out of that? Can it determine what measurements are capable through that IP? Does it know what instruments are being used, right? Who made that IP? You know, how to get in touch with the person who created that IP. So the better and more contextualized and consistent these things are in your world, the better and faster AI will be able to perform magic on those things. So the busiest slide that I have, so now we're in the transfer, right? So now, okay, we understand this idea of how is AI going to extract or detect this information from my world. Now, what types of things am I going to ask it to do for me? You know, and I can just give a few examples. So on requirements, can AI extract the requirements out of a document? Sounds like something that's right up the alley of AI and ChatGPT, you know, extract the requirements from a document. Can it generate automation from those requirements once extracted? Can it, you know, generative AI, can it create a sequence structure for me? Um, if everyone in my organization is working from the same engine, can AI then automatically match data sets regardless of, you know, site, region, product, and compare that data, right? If the structure's there, you know, data, you know, can AI help me log data in a highly contextualized way early on, by extracting the right value out of my automation and extracting the context needed for logging? Can I use natural language interface to help graph my data? And can AI help me perform a correlation exercise better, faster, right? Easier. And because, you know, this is probably, as a lot of you know, if you're in this space, this is one of the hardest things to do when you're dealing with different platforms and different engineers that call things different, and reference things differently. Um, and I could go on, right? So you could see that in this space. So in your workflow, what is the AI transfer magic that you're trying to create? And what is NI's role, NI Emerson's role in enabling that type of transfer, right? Um, it is possible, you know, in a fairly short timeline, I would think, to do these sorts of things. But how quickly that happens is going to have a lot to do with that detection component. And again, NI is spending time understanding this and creating methodologies, technologies, and tools that will help make this possible. Okay. So there's a few slides here, that I will talk to, so you'll see it here. This is really part of a technology demonstration that happened at NI Connect, our annual conference last year. And I'm going to break it down a little bit, and then I'm going to hopefully, oh, I didn't even think when I shared. Hopefully you'll be able to hear this video that I'm going to share as well. So really kind of pull some of this magic together in your mind and see what's possible through this technology demonstration. This is not a product demonstration, it's a technology demonstration, but I'll talk about what we're planning on rolling out later in the presentation here. So the first one is here. Can AI extract requirements and other information, of course, from my documentation? That might be one that you might be thinking about, because humans interpreting a document, 10 humans interpret the same document, and you'll get 10 different versions of the requirements, right? And a lot of it, you'll get errors, you'll get a lot of things. So is that possible? Once that information is extracted from your documentation, can it be put into a tool and be properly contextualized so that it can be used for valuable workflows or AI enabled workflows downstream? This happens to be a presentation of a tool we have that's called Instrument Studio. Doesn't have to be this tool, just thinking about it, extracting those requirements, grabbing the right contextualization, and putting it in a structure that AI is ready to operate on. But as I mentioned, AI, expert in the loop, human in the loop, this is just an assistant. Okay, this operation happened. It's in a tool. Obviously, it needs to be reviewed and finalized and locked in by the expert who will eventually own this. So this was just in order to get from A to B in a fraction of the time, but still empower the expert in the individual, right? Okay, now that the requirements, which means the conditions under which these measurements need to be made, is contextualized properly in an AI readable way. Can we generate a sequence structure, right? Can we put a loop in place and already knows the loops, and can it, by the way, attach to existing IP? Can it find the IP that matches the contextualization that was locked in by the detection phase, right? And can it link to that? And of course, with the expert approving, oh yeah, I know that IP. Yeah, that's the right IP. You know, so now you're matching a sequence structure with existing IP, and then that was only possible because it knew where the IP was and it can match contextualization there. Okay, now we've executed the automation and swept some parameters, and we have some data to deal with. And again, that data, as it was being executed, the right contextualization was automatically grabbed and put into a structure that is now AI ready to operate on. So now we have the first early visualizations, and we publish that information to an enterprise system, so everyone that needs the access to that data has access to that data. Because yeah, the data was captured and contextualized, but actually 6 different engineers need to look at it and do different things, right? And so that empowers the rest of the organization by publishing that data in a way that can be seen at an enterprise level. A little bit of operations. I don't have as much depth there, but okay, I want to put this test program that was created out there, and I want to run it in mass on a set of products. Where are those stations? Which of those stations is capable of running this test program and measuring this product, and help me schedule that and help me, improve my operational efficiency, in a higher volume concept. And then, get into this deeper level of analysis, how to extract the value and the learning from the data that was collected. And that's what the video is going to set up. And I think that's my next slide. Oh, well, one more slide, which is okay, but now you see the natural language interface of helping you work with that data, pull data out, push data in, look at it in different ways, and these can be can be existing tools that the AI is helping you interface with and extract value from. So what I need to do, I think when I share, I don't know that I shared audio. Let's see, include sound. There we go. So I hope this works. I will test it out and I will pause it, and then I will ask someone to confirm that they hear.
Well, let's explore this idea together.
Is that audio coming through? Can someone?
Yes, yes, Marvin. The audio is actually coming through.
Excellent, excellent. Okay, here we go. Okay, so Alejandro Beretta is one of our chief software engineers, and this is him walking us through some of the technology demonstration that I just highlighted in slides, and does it in a much better way than I do. So let's listen to
Well,
Alejandro
let's
for a few
explore this
minutes.
idea together. So I've loaded up the data that Shruti ran on stage. It is the small signal gain for our amplifier. We're characterizing the performance and the test limit for this amplifier. And I'm wondering, can we do better? I see this faint line here. I'm just going to draw this arrow here. Say, hey, Nigel, why is this so low? And just a heads up, we're going to speed up this video in the interest of time, but everything you're seeing here is real. Okay, great. Looks like the AI replied, and it's telling me that this faint curve could be because of a variety of factors, such as variability in the DUT performance, or measurement errors, perhaps at the test station, and that this curve is actually potentially bringing down my limits. And it's telling me that to further investigate, it might be useful to examine the distribution of small signal gain values more closely. So let's do that. Okay, well, the AI replied with a distribution of small signal gain around that frequency, 8.5 gigahertz. And I see here this distribution is bimodal. So I'm just wondering, I'm just going to circle these samples here and ask Nigel, examine why these samples exist. Awesome. Well, it looks like Nigel created a distribution here of the small signal gain around the frequency that I had placed my arrow. And it's giving me some statistics. But what's interesting are these observations here. So it's saying here that all of the samples come from the same test station, TS002, which might suggest a station-specific issue. And that furthermore, there are 25 different DUTs in these samples, and that might indicate that the issue is not isolated to a specific device, but could actually really be the test setup or the conditions at the station. And it's suggesting that we should examine this station. Let's ask the AI to plot the gains for all test stations for all frequencies. Great. So it looks like the AI created a chart here plotting the gains across all test stations at all frequencies. And we can see here that test station 2 is definitely lower for all the measurements. So something must be off about this test station. Perhaps it's a loose cable. We're going to have to investigate that. But for now, let's just ask Nigel to redo the first chart with the test limits, but without TS002, and show me the improvements in the performance and limits in a table, if any. Awesome. So it looks like excluding the bad test station led to a 1 dB increase in the amplifier's gain. The typical performance now rounds up to 33 dB, and that's a better number that we can include in the data sheet. This more precise characterization of the gain is a big deal in RF applications where every decibel counts. So what we just saw was that the AI analyzed our measurement data, crunched some numbers, and helped us diagnose an issue at the test station, all of which led to a better characterization of the device, which I know your customers will love, all without breaking a sweat.
Okay, awesome. Thank you, Alejandro, for that. All right. So I only have 2 more slides and then plenty of time for Q&A. So this, path to intelligent tests, intelligent validation. This is, in my world, when I meet with customers and have various conversations, but at the end of the day, this is the type of path that we engage customers on a daily basis and talk to them about how they're going to, how they're going to accelerate their innovation in their space and we're going to help them go down this path. So you can see, everyone, I assume on this call, if you're in this world, is somewhere on this path, and probably has been maybe the fifth time around on this path, because it's a never-ending path, right? So, if you have basic automation and basic measurements taken care of, and you're now to the point of where you're trying to reproduce things, do things at scale, and you're working on advancing your infrastructure to do things like be language agnostic, introduce Python into the workflow because your initial pass was maybe on C# or LabVIEW, deal with the interactive world. Think about what are your low code or no code flows. So you're developing less code. In the phase 2, you're trying to improve your operations, your ability to share IP, your ability to, have higher levels of utilization as your lab scales. Then the third phase, which is what this presentation, of course, is more focused on, is now that if you're doing things at scale, now you have data at scale and IP at scale, and that becomes its own set of problems. And how are you going to extract value out of that? So again, a continuous innovation curve, and how NIA and Emerson are positioned to help companies like yours go down this path and accelerate your way down this path. And this AI world is obviously just one of the topics in that conversation. Lastly, and as we head towards the Q&A section, I also want to set some expectations. So there was a lot of material that I wanted to present in this webinar that my CTO office told me no, because we are queued up to make some very exciting product announcements at our NI Connect conference, and this year happens to be in Austin. In Fort Worth. Sorry, normally is in Austin. If you happen to be in the area, if not, this conference is remote as well, right? For the last several years, you're able to attend this conference remotely. So whether you're in person or online, or even if you're not online, and you make sure that you tune into our webpage, a few days or a few weeks after. We are on the brink of announcing some pretty exciting things and have a roadmap to make possible some of the things that I just showed you. Well, eventually all of the things, right? The other thing I want to do about setting expectations is I am not the AI expert. So by all means, ask me about the AI software stack. One, my CTO office wouldn't let me talk about it if I could. And two, I'm not the AI expert. So just to put that out there. But in terms of applying AI and our vision for how we're going to apply AI or any other related topic in the space, I have spent 25 years in semiconductor and electronics labs. So just to set expectations a little bit. So with that, I hope there was some value in this material, and I would love to spend a few minutes answering questions.
Thanks, Marvin. So we request the participants to, ask any questions if there are any, or you can just post your questions in the chat box as well.
I can't go back to bed now, so might as well keep me up for 15 more minutes. So it's always hard to start with the first question.
I think there's a question.
Typical training time for existing data. I would love to be able to try to answer that question. Too many variables, I think. I think the thing to think about is, like I mentioned, how ready is the data? So when I've sat with some of these technologists and talked to them about where we're going down this space, one of the themes that I got from that is kind of alluded to my presentation. Let's say, AI can interrogate almost anything, if it's machine readable, right? So the question is, where do you want to spend your time? So you could sit and through a period of minutes, days, hours, you could train a local AI to understand your data. And after a long period of time, you could start extracting value. Or if you have a model that's already pre-trained and with a certain schema, um, then you can immediately start to extract value from that. So just think along that spectrum. Anything is possible. And how much time do you want to spend at some of the nuts and bolts, or how much time do you want to spend extracting real value? I think that's the thing to think about, but there's too many variables to answer or I'm not AI savvy enough to answer the question. So hopefully that was reasonable. Plagiarism issues if we use AI tools. Again, I mentioned a lot about the amount of how serious NI takes some of this space. Um, we are trying to enable organizations to extract value, and we are there to protect your IP and your data, but we are there to put you in control. So the way I understand it, and also the rules and regulations around AI, even in our own organization, is the same rules apply. At the end of the day, you're the expert, you're the engineer, you're responsible for the outcome. And so that way, AI, we are deploying this technology in a way that empowers you, does not replace you. So I think that's the best way to think about it, is we just make it easier to plagiarize. Whether you want to plagiarize, I think that is up to you and your organization's rules. So I think that's controllable and manageable if we follow some simple rules. How to master and where available more data about other AI tools. I'm not sure I follow the question. How to master and where available more data. Important AI tools for researchers. Yeah, I think you guys are. I'd love if somebody wants to chime in and clarify. It's hard to answer questions on chat without a lot of context. But also keep in mind, I'm not the AI technologist here, guys. I am not involved in creating this technology. So where these tools are and how to get value, I am more in tune with. I know what your electronics and semiconductor world looks like, and I am guiding the technologist to do it in a way that allows you to get value out of your workflow. Um, and I leave it to the technologist to talk about the tools themselves. Hopefully I'm doing some sense of justice to the question, but I'm not going to try to answer a question I don't know how to answer. How does one manage outliers in specs and measurements? Will it get lost? Yeah, great. Okay, I think I can understand that one for sure. So, you know, again, think about it as just AI is going to help you do what you normally would do. So what you would normally do, of course, is first look at your data set. The engineer needs to decide if that's an outlier. And if so, it needs to tell the tool to ignore the data, not delete the data. At least in the world that I'm used to, data is never deleted. Data is only tagged or flagged or, put under certain conditions so the tools know how to operate on it. And the engineer should be involved at every step of the way, just like you saw in the video. Okay, I think that's an outlier. Eliminate that data from this analysis, right? And the engineer makes that call. They just make that call in a very efficient manner. And the enterprise level tools need to act appropriately. And I guess unless your organization allows it, then the data is only ignored, not deleted. So, yeah, it's a great question. But again, the real question is, how easily can you get to that point? How easily can AI find your data? How easily can AI extract enough contextualization to even determine if it's an outlier? I think that is where most systems fail, even in the human world, right? that makes a big difference. Then AI just really accelerates or compresses that whole problem. It doesn't really change the paradigm. That is one of the fundamental problems is consistency and contextualization of data, IP requirements, and test system information. Yeah. It's the Achilles heel of this entire methodology and why NI is so focused in on it. We know that if we don't help you solve that problem, then you could get stuck or limited to how quickly you can innovate in this space. You know, we have customers that are partially down a path of inventing their own AI. Very smart customers. I mean, very capable. And could they do it? Hell, they're halfway there, right? They are making some progress, but they're hitting walls because they don't have enough resources to focus on this problem. So they uncover the problem, but they're not able to scale it and solve it to the level, and that's why they're partnering with us now. So I think that's where we need. That's why I say look ahead. What problem are you trying to solve? What do you want to apply AI at? And then look at it fundamentally at an engineering level of where your weaknesses are, and if appropriate, reach out to us. And this is a space that we're excited to work with everyone on. Did I miss any questions that I can answer? Adapting such systems across might get standardized across companies so that even non-AI adapters. Yeah, that's a great point. So, I mean, that's what I'm saying. There's value in standardization, period. Right. This just would be the final catalyst to really encourage people to solve the problem because the delta can be so big. You know, if I standardize an industry in today's toolings, I'm going to get 30% improvement in efficiency or whatever, but there's also some potential drawbacks so that it's not quite clear that it's worth the effort, right? I mean, I think it is, but you could be argued. With the power that you can get out of AI, I think the story becomes much clearer that this is something that has to be done or your organization can be left way behind your competitors. That's a great point. Totally agree with that statement. Okay, I see some survey that people need to take. You know, I don't know. I'm reachable. I'm on LinkedIn. The company is very reachable. You know, I'll be in India for the IESA Vision Summit in a few weeks. I forget the name of the location. Somebody can help me if they want.
It's in
But
Mahatma Mandir in Ahmedabad.
yes, yes. So I'll be a keynote speaker there. If your company happens to be at that summit, and Emerson and myself will be there, so we could do a follow up that way. I'm very passionate about this topic, and I've seen the innovations happen in the electronics and semiconductor space, but I've seen it happen over a period of my career, which is 20 or 25 years. I am extremely excited about how fast the next generation can accomplish things. You know, beyond what I could ever, you know, again, that took me 20, 25 years to even touch upon in a career of work. So, you know, the quote from our CTO, I'll end it with that, is, you know, the test engineers of the future were the ones that embrace AI today. I thoroughly believe that. I think the ones in the organization that are always there pushing things and pushing the envelope, if they can get their heads around this problem, they can create some disruptive capabilities in their space. Now is the right time, and NI and Emerson are a great partner in this space if there's a match. Okay. Any last comments or questions?
There's one last question.
Yep. Enhance my design output. and explore better optimization techniques? Are there AI-driven methodologies that can help improve results, considering the projects as confidential? Yeah, okay. I in the design space, I assume you're talking about actually electronic design space. I'm not as familiar with what's being done there. NI Emerson isn't as much, and is the EDA vendors in that space. But the last part of the question, I can try my best to touch on. Definitely, and again, I can't talk about it in depth, but I have seen the architectural diagrams from the technologists inside of NI Emerson, and we are definitely ensuring that what we do is well, first of all, we can run from the cloud, or we'll be able to run on-prem. That's one thing. Two, there's a very important split between where your data and your IP reside and what is sent into the model itself. So you don't have to send the critical data and IP to the model. What you end up sending to the model is specific questions and problems to solve. And that can abstract your IP and your data. So how a company applies this technology for a particular domain is very important. So the company has to understand this problem and this paradigm and design the architecture in a way that protects your IP and your data. And that needs, regardless of domain. And that is something that NI Emerson takes very seriously. Is it possible to, I assume there is. I believe there's some people here online from my company that can that are in charge of that agenda and my overall agenda. But let's see if there's something that we can arrange. So great question. Let's look into that.
Yeah.
Okay.
So I think we came to the end of the session, and it was really very great of you that you accepted our invitation and then hosted this webinar for us. And I think with the questions only, we can see how interesting the session was. And I think probably all the participants, would have taken the insights from your session. And we are looking forward for, one more keynote from you, in the month of March. And I think it's going to be a mega event that we are going to host it as a 19th edition of Vision Summit. Yeah. So, and we are expecting a more number of people, and it's going to be a mega. When I say mega, because we are having around 250 booths, exhibition booths, and we are expecting around 1,500 to 2,000 people to attend the event, right? So we are looking forward for that session, from you. So we at IESA, we really thank you, and all the participants, whoever has joined this webinar. We really appreciate your time and efforts to join the session, and we really hope to see in that event as well. So whoever has not registered, please register for the event. And the link has been, actually, I have put it in the chat box. You can just go through. And thank you so much. Have a good day, Marvin.
Absolutely.
And then have a great evening to all other participants. Yeah. Thank you. Thank you so much.
And thanks everyone. And again, sorry I couldn't answer all the questions, but I hope there was value in the presentation and material. And it's my honor to attend, and it's never too early to participate with a strong community like this. And I very much appreciate it, and I get a lot of energy from it. Thank you very much.
Thank you. Thank you so much.
Awesome.